Good evening, guys. Can everybody hear me? Could you please type in the chat window if you can hear me fine? Just type in yes, please. Great. Thank you, guys. Let me bring up my screen. And hopefully, can you see my screen, guys? Can you quickly give me a yes one more time? Great. Ravi, can you just give me a yes one more time, buddy? If you're able to see my screen properly. Great. Thank you, guys. Sorry about that. And let me just say hello to everybody. I'm going to switch on the video here for a moment. Let me see. So good morning, good evening, guys, everybody. And thank you for coming back. I will turn off the video. I just wanted to say hello. I see a lot of guys are coming from different backgrounds here. Looks like we have working people, we have freshers, we have engineering students, we have non-engineering research analysts, good one. We also have some students who are in 12th class and things like that, guys. So keeping everybody in perspective, let's try to continue here. Yesterday we briefly talked about data science, guys. We focused on the science of data. Today let us focus a little bit on the data and try to understand what is data. So data is a new oil. And what is special about the oil, guys? Well, in the oil there is petrol. In other words, oil is crude, and what do? We try to get the petrol from the oil. Pardon me. So today what is happening is, oil is one of the most precious resources of the world on Mother Earth. What is the meaning of data is a new oil means? Data has become one of the most precious resources of the world. Great. Thank you, Santosh. So that's what is data. Let us dig a little bit deep and try to understand what we mean by data, guys. Okay, here is a problem in the business. Generally, businesses face this kind of problems. A travel booking website books thousands of hotel rooms every day. Cool. So let's say I come here and bring this up. There it is. Let's say snap it. Put this here. One more time, go here. One more time, let me bring this up. So here is what is going on in a business. There is a travel booking website, and the book hotel rooms means thousands of visitors are coming to their website every day. And what do they booking on a daily basis? With such a huge growth, the task at hand is to improve the booking per customer. In other words, a lot of customers are coming to their website. Maybe they are not making their bookings. What do they want to do? That is what they want to do. They want to improve the booking per customer by showing the best hotels. In other words, maybe the reason the visitors or the customers are not booking at the website is because they are probably not being shown the right hotels. And that is why they're probably not booking. We are not sure. Okay, so what do? We have to somehow try to understand and find the best hotels based on the taste and preferences of the user. What is this? This is the problem of a business. In real world, we generally work on problems like that, guys. So give me a quick yes, guys. Everybody okay with this slide? Good. So let's move on to the next slide. And here is an example of data. Let's see what that means. Imagine what we are doing is we collected some data. How do we collect the data? We'll talk about that in the coming up days. And let's move a little bit here. So take a look at Hotel 1. Hotel 1 has a good gym, but it has a small pool. Take a look at Hotel 2. They have an amazing gym. The gym is really great, but they don't have a pool. They don't have pool. Hotel 3 also has a great gym, but the pool is small. Okay, then Hotel 4 has a basic gym, which means the gym is very, very basic and it's not really great or things like that, but their pool is very, very good, or a large pool. Then Hotel 5 does not have a gym, but what does it have? It has a very large and a beautifully designed pool. What is this one? Imagine we went to a few hotels, we observed them, we tried to collect some data. That is what this is. We're calling this as a sample set. Let's also take another example. Here is a few users. What did we do? After we collected the data of the hotels, we imagine we are making a few calls to a few customers. And here is John. What is special about John? John prefers gym over swimming pool. Swimming pool is not really a must for him, but gym is a must for him. Then comes Kevin. Kevin also looks like he likes gym more than pool, so pool is not so important. Gym is a must, or in other words, gym is important. Then comes Bill. Bill needs a pool, but gym is not, and just a basic gym. In other words, his preference is more swimming pool. Then we have France. A pool is a must. He doesn't go to gym. He just uses the pool. He's maybe into swimming and things like that. Everybody okay with this slide, guys? Quick yes, please. Okay, so what do we do? Well, let's move a little ahead. Take a look at this. So now let's come back to Hotel 1. Hotel 1 has a good gym. So what do? We're going to give a rating to it. We'll call that as 0.8. We're giving a high rating on a scale of 0 to 1. Because the pool is small, we're just going to call that as 0.2. That is the story of Hotel 1. Then come to Hotel 2. It's an amazing gym. So what do? We say we give it a 1. Since there is no pool, we're going to give it a 0. Then come to Hotel 3. The gym is great. So again, one more time, we're going to give a high rating to the gym. But for the pool, we're giving a small rating. Then for Hotel 4, the basic gym is basic, but the pool is large. So we're giving a high rating to swimming. Then come to Hotel 5, no gym. So there's a 0, but a large and beautifully designed pool is what they have. So we are giving a high rating. What is this? For the sake of simplicity, we are going to call this as a feature matrix. It's a double-dimensional data is what it is. And that is the story of the hotels, guys. Let's move one step ahead and now take a look at this. From here, put this. Now what is happening is, here is John. What is the story of John? Well, John prefers gym. For him, gym is more important. So what do? We're giving a high rating for gym. For swimming pool, we are giving a low rating. We're following a similar process. Then comes Kevin. Kevin likes gym. So for Kevin also, we're giving a 0.8. And for pool, we're giving a 0.2 because he likes gym more than pool. Then come to Bill. Bill needs a pool. So what is this? Bill needs a pool means for pool, we're giving a slightly high rating. And for gym, we're giving a slightly low rating. Then come to France. For France, a pool is a must. So what we are doing? We're giving a very high rating and we are not giving any rating to France. So what is this? This is the information between the users and the preferences, whether they like gym or whether they like pool. And this is the information between the hotel and the preferences or the characteristics of hotel, you can also say. So what is this? This is an example of data. Everybody with me so far, guys? Can you give me quick yes? So we are talking about the topic called data. What is data? So now take a look at this, guys. What is happening is, so I come here. Take a look at this. Take a look at John. What is John? John gave a high rating for Hotel 1. He gave a high rating for Hotel 5. Looks like he did not visit Hotel 3. He did not visit Hotel 4. And he gave a low rating for Hotel 5. Then come to Kevin. Kevin doesn't look like he visited Hotel 1, but he has given a high rating for Hotel 2. For Hotel 3 also he has given a high rating. Come to Hotel 4, he did not visit Hotel 4. And for Hotel 5, he has given a low rating. Okay, then come to Bill. Bill, for Hotel 1, he is somewhere medium. Okay, Hotel 3, Hotel 2 also, maybe he is somewhere in the medium. He did not visit Hotel 3 and he has given a high rating for Hotel 4. He has given a high rating for Hotel 5. Then come to France. France, low rating for Hotel 1, did not visit Hotel 2, did not visit Hotel 3, did not visit Hotel 4, and he has given a high rating for Hotel 5. So, what does that mean? Well, let's go one step ahead. If you take a look at this, what is happening is, Wherever there are orange colors, the orange colors are indicating these users have not visited them. So Kevin did not visit these, and here is the bill. We did not visit them, and France did not visit any of those things, guys. Okay. So what do we do? What we do now, if you focus on the greens, if we now focus on the greens, what we are observing, we can say, notice John and Kevin have given a high rating to Hotel 2, and John and Kevin have given a high ratings to Hotel 2. They have also given a low rating to Hotel 5. In other words, we can say whatever John seems to be liking, Kevin seems to be liking, which is this. They both seem to be liking. And it looks like what John doesn't like, Kevin also doesn't like. So it looks like they are not liking Hotel 5. So we can call these two guys as similar users. Okay. Now let's go one step ahead. Come here. Take a look at this one. If you take a look at the reds, what is happening? Take a look at Bill. Bill has given low rating to Hotel 1 but high rating to Hotel 5. France has given low rating to Hotel 1 but has given high rating to Hotel 5. In other words, whatever Bill seems to be liking, it looks like France is also liking. Whatever Bill doesn't seem to like, it also looks like France doesn't seem to like it. So we can say these two seem to be similar. Okay, from the previous one, we can say John and Kevin are similar. From this one, we can say Bill and France are similar. What are we doing? We're trying to, based on their taste, we're trying to understand who is similar to what and things like that, guys. So now imagine Kevin comes to our website. And what is he doing? Well, he's looking around, he's browsing for different kinds of hotels and things like that. So what can we do? Well, what we can do is, we understand that Kevin is similar to John. So what can we do? It looks like John has given high rating to this hotel. So what do we do? Well, if John likes something, Kevin is also liking something. So what can we do? This is the first recommendation we can give. Okay, everybody with me, guys. Quick yes, please. Can you type in yes? Are you so far? Bill. Okay. Let's see. Let's go one step ahead. And now imagine John comes to the website. So I come here. Put this here. So now what is happening is John is visiting the website. What is happening? He did not visit Hotel 3. But what is special? John is similar to Kevin. And what's happening? Kevin looks like he liked it. And if Kevin likes something, John also seems to be liking it. So what can we do? For John, we can recommend Hotel 3. Along the same lines, let's go one step ahead. Let's come to France. Come here. Where is this? This is. Put this here. Put this here. Choose this one. And here comes France. What is happening? France did not visit this one. But what is special about France? He's similar to Bill. And what is Bill doing? Bill has given a high rating to this, which means if Bill likes something, France will also like something. Since Bill has given a high rating to this one, what can we do? We can recommend this one to France. Okay, that is the story of France. Then, okay, so in other words, that is what is happening, guys. That is how, what is this one here? We have a group of maybe 3, 4 or 5 users. So what we are able to do is we are able to manually look at them. We are able to understand who is similar to what and what they like and things like that. But in a real world, when you have hundreds, thousands and millions of customers, it is not possible for us to put the data together like this and be able to understand who likes what and things like that. It becomes very, very complex and it becomes very, very time consuming. What do? That is where the machine learning comes to rescue. These are called the recommendation systems. What are recommendation systems? Recommendation systems are working based on the data. We provide these recommendations based on the machine learning algorithms and things like that, which are based on data. So this is an example of data. Everybody with me so far, guys? Can you give me a quick yes, please? Okay. Okay. So we'll look at more examples like that, just in case you did not get that. So let's make a little bit progress, guys. What is data? Data is the foundation of analytics. Imagine you want to build a house. What is the first thing you do? Well, you build a foundation. Data is the foundation. in order to perform the data analytics, guys. Okay, that's why it's called data analytics. Before starting any analysis, we need to understand the characteristics of the data. We need to understand its source of origination and transformation it has gone through. Okay, so in other words, what we need is data, but what is more important is we need good data. So what do? We try to understand if the data is good or not. That is what is understanding the characteristics, making sure it is coming from the right source of the data, and making some changes on the data, which is referred as transformation. We'll try to understand these things in the coming up months, guys. If we go a little bit deep, there is different types of data. There is qualitative data and quantitative data. So if you come back here, there is a set of qualitative or quantitative variables. And what is qualitative? Qualitative is descriptive in nature, which means it describes an attribute that can be observed but not measured. You cannot measure it. For example, if you take different types of ice cream, vanilla, butterscotch, and chocolate, what is it? Well, that is textual data. What is textual data? That can be referred as qualitative data. You take the color of hair, black, blonde, or brunette, that is also textual data. Take the profession type, that is also textual data. Engineers, tailors, and consultants. So that is called qualitative data. What do? You don't measure them. These things you don't measure. But come here. Something which you can measure is called quantitative data. It is a numeric measure. We can perform numerical measures. Okay, for example, if you take a group of students and take their heights, you can calculate the minimum, you can calculate the maximum, and things like that. Mean, median, and things like that. So the same, you can perform the minimum, maximum for the cost, then for the age. What is that? That is called quantitative data. Quantitative data is measurable. Everybody with me, guys? Quick yes, please. Cool. Okay. So let's dig a little bit deep. We can also categorize the data in a few more ways. What is it? Based on the type, based on the processing, based on the form, source, and size. Let's look at a few of them, guys. Here is types of data. One more time, categorical data and quantitative data. Categorical data is textual data. Quantitative data is numerical data, which we just discussed. In categorical data, we further have more types of data. Let's take a look at some of them. So here is binary data. Binary data is something where you have two choices. Cool. So that is 0 or 1. Two choices there. Toss a coin, you get head or tail. On or off, two choices. Dot and dash, two choices. What is that? That is called binary. Binary means you have two choices of data, guys. As simple as that. Let's go one step ahead. Here comes nominal data. Nominal data, imagine you take a group of books in a library. This is a shelf in a library. There are a group of books which are fiction, group of books which are humor, group of books which are travel. In other words, these things are acting like a category. What is that? That is nominal. What is special about it? It is categorical. What is categorical means? It is textual data. It is coded. Means it's like a category. Category is acting like a code. It represents a label. Category or a label. You can only count but cannot order or measure. Which means whether you put fiction first, humor next, and then travel first. Okay. Or you reverse the order. Okay. It is still the same. Or in other words, let's take this one. Names of cars. You take Honda or Toyota. You say Honda or Toyota or Honda. What do? You don't measure it. It is not used for measuring. What is it? That is textual data. So similarly, book titles, whether somebody is married or unmarried, or you say bachelor or married or bachelor, still it is the same thing. What is that? That is nominal data. In other words, it is textual data. If you change the order, nothing changes. There is no meaning changing. Everybody with me, guys? Quick yes, please. Okay, so let's move to the next one. And now here comes the ordinal data. Let's see what we have here. Ordinal data, the data is ordered. If you take a look at the group of medals, what is Russia? Russia, Norway, followed by Canada. If you notice this, Russia has 33 total, Norway has 26, and Canada has 25. But notice USA has 28. Even though it has 28, it is in the fourth position. It is not in the second position. Can any one of you take a guess why it is in the fourth position, not in the second position, guys? Good. More precisely, take a look at the golds. If you take a look at the golds, Russia got the highest number of golds, followed by Norway, followed by Canada, and then followed by USA. So in other words, what is happening? What is Russia? If I do a little bit of cleanup, you take Russia. Russia is a group of athletes. Norway is a group of athletes. So it's acting like a category. Okay. And what is it? It has a natural hierarchy. What is the hierarchy? Based on the number of golds you are putting. You are putting them in a descending order. The intervals between the ranks may not be necessarily equal. How many gold or medals Russia will get, Norway need not get the same number of medals, so Norway need not maintain an interval. It depends really on their talent and things like that, guys. So the interval is not really meaningful here. So what is that? Here, what is important is these are all textual data. The names of the countries are textual data, but what is happening is there is an order here. There is some implicit order. The one with the highest number of golds in the top, followed by the next one, followed by the next one. The one on the top is the greatest one, followed by the next one, followed by the next one. What is that? That is called ordinal data. Everybody with me, guys? Quick yes, please. Cool. So that's another one. Let's move a little ahead. Okay. Let's see what's an example of discrete and continuous data, guys. Discrete. Numerical data, finite number of possible values, which means an example is number of people in a room. What does that mean? Well, if you take number of people in a room, there is a limited number of people. There can be 5, 10 or 15. You don't say there is 1.5 people or 15.5 people. What is that? That's like a whole number. What is that? That is discrete data. Number of items in a basket, you don't say there are 5.5 items. You say 5 or 6. That's a whole number. Number of hours in a day is 24. Whole number. What is that? In other words, that is non-decimals. Discrete data is like non-decimals. Come to continuous data, it is also numerical data. It has infinite number of possible values. If you take 0, and then between 0 and 1, there are infinite number of values. Okay, you can say 0.1, 0.01, 0.001, and you can keep on like that. What is that? That is decimals. What is that? That is continuous data. The height, weight, sales, and everything is decimal. That is called continuous data. In a statistical world, what do we do? These are the terms that we generally use in a statistical world, guys. Everybody with me? Quick yes, please. Okay, so let's see what else we have. There you go. Let's touch a little bit of raw data, guys. Today, everything is about data, but what is important is everybody has data. And let's see what is important about the data. Raw data means it is data from the source. Today, what happens, guys? I'll give you an example. Oops. Okay. One second, guys. There you go. Okay, so imagine, let's say for the sake of simplicity, I will take a slightly. Okay, let's take Bollywood for example. For the sake of simplicity, here is Shah Rukh Khan. Okay, let's take this as Salman Khan. And what's happening? Here is Starbucks coffee. Starbucks coffee, what they would like to do is they want to either choose Shah Rukh Khan. Oops, undo that. Let's come here. They're coming up at they want to choose either Shah Rukh Khan or Salman Khan. Now what is happening is they go to their IT department and they ask them, hey guys, can you help us? The IT department will tell them they cannot help you. Why? If you want an application to be built where you enter some data, you save it to the database, complex kind of data, they can help you. But if you want them to help you decide whether you should choose Shah Rukh Khan or Salman Khan, they cannot help you. What will the business do? The business can now go to the data analytics team. And what can the data analytics team? Data analytics team can help them. What will they do? Imagine the data analytics team goes to internet. And what are they doing? They are downloading all the data of Shah Rukh Khan from internet. They're accessing his tweets, they're accessing his Facebook comments, social networking sites and things like that. And then here is Salman, they're also accessing his data. And what is that? That data is raw data. The data that you are downloading from the original source is raw data. input to the data process. So what do? We take the raw data, we try to process. Why? There may be errors in it. What does that mean? Imagine, let's take one guy from our list. Let's take Vikas. We have one of the guys, one of the persons who is attending. Here is Vikas. Vikas is a fan of Shah Rukh Khan. So what he did was, he goes to every site, Twitter, Facebook and things like that. And what is he doing? He's using the username Shah Rukh Khan, Shah Rukh Khan, Shah Rukh Khan. So now what can happen is the IT team is downloading the data of the Shah Rukh Khan and thinking that is Shah Rukh Khan. And what is happening? That is actually Vikas. What is that? That's an error. So what is the problem? It is not validated. The raw data is not validated. Okay, what can happen? Vikas may have visited Starbucks coffee. And what did he do? Well, maybe he did not like it. So he's in his tweets, in his Facebook comments, in his social networking sites, he's saying, guys, I went to Starbucks, I did not like it. And now what happens? The world might think that Shah Rukh Khan was not liking it. Okay, that will be a big impact. Why? Because he has a lot of followers. What can also happen is it can be multiple forms. In other words, let me do a little bit of cleanup here. The data can be in multiple forms. If you go to Twitter, the data is in the form of JSON. If you go to Facebook, it's in HTML, XML, and many other forms. If you go to other social networking sites, it's not formatted. We need to format it. What is that? That's raw data. It can be dubious. It is Vikas who is opening it as Shah Rukh. What do? You need to verify it. Okay, what are these? These are some of the problems with raw data. And what do? Well, here is a more simple example, or that's what I have given you is a much more practical example from business perspective. But here is a much more simple example. If the correct format is not specified in an application form, the date of birth data can take many forms, such as 31st January 1990, 3101, 3101, and things like that. In other words, the same date can be written in many ways. What do? Imagine a group of people are taking a survey. They're going from home to home and they're filling up a survey. And as they fill up the survey, when they have to enter the date, they're entering it in different forms. That is what is happening. Okay, so when they take this data and when they enter into the application, what do? The date will be taken in different formats and it will be standardized. It will be converted to a standard format so that it becomes easier for other applications or other people to use it. So what is happening? Raw data can come in many forms. That is one example of a raw data. Okay, so let me come back here. Everybody with me, guys? Can you give me a quick yes, please? Okay, so now come back here. What do? Well, we process the data. Generally, when we have raw data, the next step that we do is we process it, which means data after processing for issues in the raw data. It is Vikas who is opening everything as Shah Rukh, Shah Rukh, Shah Rukh. But what do? You process it. You make sure that it is Shah Rukh. Shah Rukh. Now what happens if Vikas opened everything as Shah Rukh Khan because he's a fan of Shah Rukh Khan? Shah Rukh Khan, when he actually comes to Twitter, Facebook and things like that, what will happen, guys? Well, he's not able to find his username because his fans are using. So what will he do? Maybe he'll open something like a Shah Rukh Khan 1 or a Shah Rukh Khan 2. What do? You need to process and you need to understand that. What do? Once you figure out who is Shah Rukh, it is ready for further analysis. What's happening? This processing includes scrubbing, cleaning, merging, formatting and transforming. These are some of the steps that we perform in order to make sure it is ready for analysis and make sure it is not the dubious data and things like that. All these steps are documented. So generally based on when you work in businesses and enterprises, so based on domain to domain, scenario to scenario, there are various steps. Some of them will be documented, some of them may not be. As you come up with new steps, you generally document them. So here is, again, that's a practical example, but let's take a look at a slightly more academic example. Recording number of children field in a survey form may be left blank by people, which means a group of representatives are going from home to home and they're asking each house, hey, how many children are there? Well, in some houses, you may not find any children because the children are grown up. So they don't have any children. So what is happening? Some of the representatives are leaving it as blank. What do? Well, when you enter, when you see the people who are entering the data into an application, when they see a blank, what is happening is they leave that field as a blank and the application is converting it to 0. Or maybe when they're entering the data, we have trained them so that if they see a blank, enter it as a 0. What is that? That's a simple example of a processing. Another example is end of day sale amount, which means you take sales and what can you do? You can sum them up, you can calculate the mean, you can calculate the median, you can perform various types of statistical calculations. What is that? That is called processed data. Everybody with me, guys? Quick yes, please. Cool. Okay, so let's move a little ahead. Let's see what else we have. Generally, what we do, guys, here's what we do. This is how, these are some of the ways of collecting the data. There are a lot of other ways, but here are some of the ways of collecting the data. The census. Census is where generally it's a systematic collection of data about all members of the population, which means you generally go from home to home and then you collect the data. That is called census. Then you have observational study. What is observational study? Collection of data to draw inference of outcome of a treatment on subjects. That is like a formal definition. It is not in control of the investigator to assign the subjects either to test or the control groups. Again, a formal definition. Observational study can be thought of as, imagine a hospital, there is a doctor, he has a group of patients. Let's say a company has come up with a new medicine for COVID. And what is happening? Well, they want to test it on a few people. Now they come to the doctor. This doctor is a popular doctor, so they come and they request him, hey buddy, we have a medicine which we want you to use it on your group of patients and observe and study. So now what the doctor is doing is he's given this medicine to a group of patients. For a few days he's observing them. And then what is he doing? He's making a note of the results. What is that? He's observing it and then he's making the notes. The notes is the data. So what's happening? He's collecting the data by observing them. That is called observational study. Then we have convenience sample. What is the doctor doing? The doctor has given it to the group of patients in his hospital because they are convenient. It is convenient for him. Okay, and what is he doing? He is collecting the data. The results is nothing but the data. What is this? It can also be said as convenience sample. Randomized trial. Now imagine this doctor has what he would like to do is he doesn't want to restrict it to his own hospital, but he wants to pick up some random patients from different hospitals. What do? He is going to different hospitals and he will advise them, hey guys, give this medicine to a group of patients to randomly and then give me the results. So what's he doing? He's collecting the data, how? In a random way. What is that? That is called randomized trial. Everybody okay with this slide, guys? Quick yes, please. Okay. Then, so what is that? That is called sampling. So this is where sampling comes into picture, guys. Okay. So let's dig a little bit deep. Why sampling? Why not analyze the population data? So let's see. So take a look at this. Here is, come here. Population versus sample. If you go back to school, we have touched a little bit of statistics and things like that, guys. What is population? It is a complete set of items that have common properties which are subject of statistical analysis. In other words, let's say this is a group of people. What's that? That's a complete group of people. We're calling that as a population. What is a sample? A sample is a subset, as simple as that. Okay. So what is special about this sample, guys? Notice almost every one color. There's a blue here, there's an orange, there's a green, there's a red. In a statistical world, what we say is this is called a representative sample. Is what it is. What is important is it is not just enough you have some random sample. The sample should be representative. So let's say each color is representing some specific characteristic what you need to have. So let us say, for the sake of simplicity, okay, so stick with me, guys. We'll try to understand that. What is a representative sample? Why sampling? So why sampling? Sampling saves cost. It is less expensive to study the sample and the population. It saves time. Less time is needed and we can understand the characteristics of the population. We generally try to get, accuracy is not guaranteed, but we generally try to get an accurate picture based on the sample. Then what do? We need to make sure nothing is missing. What's an example of this? Let's take a look at this. Let's go one step ahead. Take a look at this. So here is an example. Analysis requirement. We need to study the salaries of offered to engineering graduates in 2014 in India. Okay, in other words, we need to understand, we want to know what are the people who graduated in 2014, all these guys who are coming from engineering colleges, what is their average salaries, what we want to understand, what are their salaries look like, is what we want to understand. So what is going to happen? The population is all the engineering colleges in the country is the population. And what is happening here is a sampling frame. Sampling frame is, what do? We cannot go to every college in India and we cannot try to find everybody who graduated in 2014 because they're scattered all over. So what do? We try to define a sample. What is this sample, guys? Take a look at this. Engineering graduates, they're all engineering graduates. They passed out in 2014. We will pick a few of them. What we are interested is, imagine the requirement is we are taking all those people who have been recruited in campus. We're taking them from all the branches. We're taking them from all the tiers of colleges, which means IITs, non-IITs, Birlas and non-Birlas and things like that. Then we're also taking which are all the companies, IT, non-IT and industries and sectors also. So what are we doing? We're kind of defining a sample. And what is the sample? We cannot go to everybody, every engineering graduate. What do? We generally go to a few cities, few major cities, and we try to find a few people who have this kind of characteristics. What is that? That is called a sample. Okay, guys, short and sweet. Sample is nothing but a subset, guys. Everybody with me? Quick yes, please. Okay, so let's go one step ahead. So take a look at this. If you go a little bit deep into sampling, come here, put this here. So where we are. In sampling, there are two kinds of techniques. One is called probability sampling, one is called non-probability sampling. Probability sampling is a sampling method where each member of the population has a known probability of being selected as a part of the sample. Which means, imagine a group of students with boys and girls. You randomly pick up somebody, and what's happening? Well, everybody has a chance of picking up. Everybody has a probability. That is what is called probability sampling. If everybody has a chance, it is not biased. But imagine non-probability is where it is a method where some members of the population have no chance of being selected. Which means, imagine there's a group of boys and girls in a class and you separated the boys and the girls and now you want a subset or sample. What are you doing? You're just choosing from the boys or maybe you're just choosing from the girls. What is that? You're excluding some. What is that? That is called bias. In other words, your sample is biased. That is not fair. In other words, that is slightly partial. Everybody with me, guys? Quick yes, please. Are you catching it? Okay, let's go one step deep. In non-probability sampling, these are the different kinds of sampling techniques that are there, guys. So let's see, I'll give you a slightly high-level overview. I'll try to give you a slightly high-level overview. Non-probability sampling has something called accidental sampling. It is selected which is readily available. Okay, and let me come back here. There it is. Okay, so at a high level, we have four types of sampling: accidental, quota, judgmental, and snowball. Let's dig a little bit deep here. Let's with an example and try to understand them. So these are all the non-probability sampling techniques. What's happening? Well, John is an Android developer. He takes the help of his friends, Ted Bird and William, to study the market before releasing an app developed by him. So in other words, John developed an app and he's asking his friends, guys, I need your help. I need you to, before releasing this app, I want to understand if this is being liked by them or this is not being liked by them. So he's asking his friends to help him. Okay, they identify the local shopping mall. Let's do a little bit of cleanup. So here's a local shopping mall. They said here's a shopping mall as the best place to do the survey. So he's asking his friends to do the survey. Okay, so what is happening? Here is what is happening. Here is accidental sampling or convenient sampling. Ted is one of the guys, one of his friends. What he's doing is he's targeting all the people entering the mall to fill the survey. So what he's doing is he goes, stands in front of the door. As and when people are entering, he's asking everybody. And what is happening? He's collecting the data. So he's collecting the data. What's happening is everybody is accidentally coming across Ted. And what is that? That is called accidental sampling. Maybe when they fill up the survey, they give some benefits to them, some special privileges to them and things like that. So next comes judgmental. What is judgmental? BERT targets only college students. In other words, what BERT is doing is, he gave a thought and he thought this app is only used by the college students. So what is he doing? He's using judgment. Then he's filling up the survey. When he fills up the survey, data is getting collected. That is called judgmental sampling. Okay. Then you have quota sampling. Let's do a little bit of cleanup. Quota sampling is William. Come to William. William wants to ensure there is an adequate representation of men and women. He decides on a quota of 3 men to 1 woman. So what is that? William is thinking it might be possible that Bert and Ted may have ignored all the boys or the girls. So William is giving a thought, okay, we should have a good representation of men and women. So what he's doing, he's filling up he's getting the survey done, and that is called quota sampling. The last one is snowball sampling. What is snowball sampling? John focuses on getting references. In other words, John convinces one guy and he fills up the survey. This one guy gives his 2 friends names. Okay, these 2 friends will further give 8, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3 is 8. So, or maybe 4, sorry. 1 will give 2, and again these 2 will give 4, the 4 will give 8, and it keeps on going. What is that? That is called snowballing. What is snowballing, guys? If you have a big mountain, a small flake of snow starts there. As it rolls down, what is happening? It is becoming a very big snowball. That is called snowballing. Okay, everybody okay with this slide, guys? Can you give me a quick yes? Okay, so let's say come back here. Then we have probability sampling, guys. These are again some of them. We have something called simple random sampling, stratified random sampling, systematic sampling, and cluster sampling. For today, I will not go into these things, but what are these things, guys? These things are the concepts of statistics. Okay, guys, in statistics, what do we do? As data scientists, we use some of the concepts of statistics. We try to use a statistical thinking and try to understand some of the concepts. So that's where we use, guys. Okay, so let's dig a little bit deep into a story of statistics. Alan went for a trek. On the way, he had to cross a stream. Come here, put this here. So there is Alan. He has gone for trekking. On the way, he had to cross a stream. Alan did not know swimming. He needs to cross this, but he doesn't know swimming. He started exploring alternate routes. So he's looking for an alternate route. Suddenly, he saw a signpost which said average depth is 3 feet. Alan was 5 feet tall and thought he could safely cross. So naturally, if you're 5 feet 7 inches and it says it's only 3 feet deep, anybody would think they can cross. But what can happen? Here is what can happen. What is it? Well, the signpost is indicating it's only 3 feet in depth. But what is happening is, if you take the depths at different points, there are some places where it might be more than 3 feet depth. And if you do not know swimming, there is a good chance you might get into trouble. So what is average? It is a concept of statistics. Average is one of the concepts of statistics. So what does it mean? Well, that is one example of where we are looking at using the right metrics for statistics, guys. So everybody okay with that example, guys? Can you give me a quick yes? Okay. So statistics, guys. What is statistics? Well, you have different kinds of measures and metrics, and what do? You visualize the data, you try to understand, and things like that. If you have the heights of male and female, we can come up with a bar chart like that. If you have, so here height is numeric, and male and female is indicating textual data. So in other words, you have on y-axis numerical data, on x-axis you have numerical data. On x-axis you have textual data. But if both on x-axis and y-axis you have numerical data, what do? Well, we can come up with a plot like this. This is called a scatter plot. Okay, in statistics we perform this kind of visualizations and things like that. Back to population, guys. Population is a group of people. It might be a group of people in a colony, or maybe a district, or maybe a state, and things like that. Sample is a subset. What do? Well, if you take a look at this in a statistical world, In a statistical world, when we take a sample of people, we can identify their gender, we can identify their age, we can identify their height, we can identify their weight. Okay, so there is gender and age for every person. So what are these things? These things are called variables. Okay, they are like characteristics, but for the sake of simplicity, in a statistical world, we call them as variables, and you can get the data. So this is acting like data. Now what can we do? We can do, when we have this data, we can perform various kinds of operations. What are they? Well, if it is numerical data, what can we do? We can, for example, if you take the height column, here is the numeric data. Say, come here, put this here. What can we do? We can try to summarize it. You can try to understand what is the mean, what is the median, what is the average, what is the midpoint. We can try to visualize the numerical data. You can come up with bar charts, pie charts, and things like that. We can try to understand outliers and things like that, guys. Those are the things we'll be talking a little bit in the coming up days. That is, so more precisely, in the variables, we have two types, which is categorical and numeric. Categorical is textual data. Okay, and numeric is numerical data, is what it is, guys. And what we do with this kind of data, we can perform different kinds of operations. There is numerical data. For numerical data, we perform this yellow color. For textual data, we try to summarize and say how many males are there, how many females are there, and we try to visualize it, guys. So notice the yellow colors are the textual data, the green colors are the numerical data. What is special here, guys? Well, there are blues and pink colors here. And what are they? What is special? All the blues are the males. Okay. And all the, sorry, they're not males. They're specific group. Maybe they have something special and things like that. They are an adult, child, and male. Female, male, and male. For a moment, I thought all the blue colors were the males. But it looks like one of them seems to be female. Maybe that's a typo. I think this should be a male, guys. Okay. Because if you look at that, that's a male. More precisely, all the blue colors are male. All the pink colors are female. So this is a typo here, this is a typo here. We just need to correct it. What do? We can visualize the data. If it is a textual data and numerical data, you can use bar charts. If both of them are numerical data, you can use a scatter plot like that. Then we perform various kinds of tests. One sample test, chi-square test, t-test, ANOVA. These are some of the things I will give you a touch of it in the coming up days, guys. Okay. And we'll try to understand what is the significance. Generally, slightly at a high level, if you have only one categorical variable, which is like if you just know whether somebody is a male or a female, if you had only one variable, we perform one sample proportion test. If you have two categorical variables, then we can perform chi-square test. If you have only one numeric variable, we perform a t-test, one numeric and one categorical. We can perform a t-test and ANOVA. If both of them are numerical, we can perform a correlation test. What are these things, guys? These are different kinds of hypothesis testing. Again, this is just a quick introduction I'm giving. I will briefly touch about these things in the coming up days. You take a question and a hypothesis, we perform different kinds of hypothesis testing and analyze the data, guys. Okay. So what is that? That is hypothesis testing. What is hypothesis testing? Let's try to understand, guys. Everybody doing okay so far, guys? Can you give me a quick yes? Cool. Okay. So now imagine you're a data scientist and what is happening, or imagine you have been given a group of data scientist salaries. So here are a group of data scientist salaries. Let's say we have been given 30 data scientist salaries. And here are the salaries. If you take the lowest value, it is probably $80,000. If you closely look at this and look at the highest value, it is probably $113,000, $114,000. Maybe it could be more. Okay, we have taken about 30 data scientist salaries and we are trying to understand that. Now, what do we do, guys? The first thing we could do is we can calculate a mean. Mean is the average. Okay, we can also calculate the standard deviation. Then we can, the standard error, the z-score, the z-value, all these are statistical concepts. Ideally, what we will do, we will take this data, we will give it to a function. And what does the function do? The function, after it calculates the mean, it calculates the standard deviation, it will calculate the standard error. Standard error is nothing but standard deviation by square root of n. Then we have something called reliability factor, which is based on the z table. It will pick up the value. There is another thing also called confidence level. What is a confidence level? A 95% confidence interval means you are sure that in 95% of the cases, the true population parameter would fall into the specified interval. That is more of an academic definition, guys. Let's try to understand what that means. Take a little bit more deeper look. Now, look at this one. Ideally, in a statistical world, we would take the data, we would give it to a function, it would calculate this value is called a z value. Okay, it will use a z table and it will calculate that value. What are we getting? We're getting 94,000 to 105,000. What are we saying? We are 95% confident. Based on this 95% confidence, that value is being picked up by the tools. That could be Excel, that could be Python, that could be R, and things like that. And it is coming up with these values. What is this? This is indicating, we can translate this and say, with a 95, we are 95% confident that the average data scientist salary will be between somewhere $95,000 to $105,000 is what we can translate it into. That is what they are making in USA. This is the data of USA. They make anywhere from $95,000 to $105,000. What is special? We are saying we are 95% confident. Now that's a little bit of statistical thinking, guys. I cannot, I will try to explain a little bit more in the coming up days, but let's go one step deep. At a slightly statistical level, we can also be 99% confident. The same thing we are translating it and saying we are 99% confident the average data scientist salary is going to lie between 93,000 and 107,000. In other words, imagine, let's say here is 93, here is 95, here is 103, and let's say here is 105. What we are saying is, we are 95% confident it is between $95,000 and $103,000, and we are 99% confident it is between $93,000 and $105,000. What is happening is narrower, but only 95% confidence. In other words, 95% is narrower, 99% is much more wider. The more the wider, the more the difference between them is happening. Okay, the more the narrower the width is decreasing is one way to think. What is this? More precisely, whether you are 99% confident or whether you are 95% confident, this is called statistical thinking. What do we do as data scientists? We use this kind of statistical thinking and we try to apply it in a business world. Everybody with me, guys? Quick yes, please. There is a lot more I can talk and explain, but for now, my objective is I'm just getting you familiar. I don't mean to make you an expert, guys. It's too early for me to make you an expert, but that is called statistical thinking that we use. And let's go one step ahead. Take a look at this. So here is Sam and Paul. Let's see what is happening. Sam and Paul are throwing darts. They're throwing darts at the local sports bar. A few of their friends started betting pool. So some of the friends are about to start a betting pool. Both Sam and Paul shoot 10 practice shots each so that their friends can decide whom to bet on. So this is like a trial. And what is happening? Well, notice Sam. Sam has got 4 bullseye. And what is special about Paul? Paul has got 5 bullseye. So what should we do? Well, we need to decide who is better, Sam or Paul. So imagine if you were to be asked that question, who do you think is better, guys? Is Sam better or Paul better? So I see some of them are Sam, some of them are, many of them are Sam. That's a good one, good sign. So what is important is, let's say, choose this one. Sam, what is happening is, notice his spread. How much he is. The spread of his darts is much more smaller compared to Paul. The spread of Paul. What is this? This is called the variance. Okay. So in other words, let's say, who is better? Sam is better. That is a concept called variance. What is variance? Variance is about the spread. If you are, let us say, let me try to give you another example and see if that helps you guys. Let's take this one. Imagine Sachin Tendulkar. Let's do a little bit of cleanup. Sachin Tendulkar in the first game, he scored 0. In the second score, let's say, put this here, he scored 100. So what's happening? Well, this is his spread. But here comes Dhoni. Okay, what is Dhoni? In the first game, let us say he scored 40. In the second game, he scored 60. What is happening? Well, here's what is happening. If you take the average of both of them, it will be somewhere in the middle, that will be 50. Okay, so what can we say? Both Sachin and Dhoni are same. But what do? If we try to understand the spread, which is, this is the spread of Sachin versus this is the spread of Dhoni. The spread of Dhoni is much more lesser. If the spread is less, your variance is less. If your variance is less, you are more consistent. There is a good chance you are more consistent than somebody whose spread is more. Sachin, we can say, is less consistent. So what is variance? Variance is indirectly telling you who's more consistent. And here we can say Dhoni is more consistent. If your spread is less, what do? You are a better one to bet on. This is again, one more time, called as statistical thinking. Everybody with me, guys. Quick yes, please. Good? Good, guys. Okay, so let's move a little ahead, guys. Today, I'm focusing a little bit on statistical concepts, trying to get you with slightly familiar with the statistical terminologies, guys. These are the terms that we'll be using in the coming updates, and we'll try to see them, guys. So let's see what we have here. How many of you think Earth is the center of the universe, guys? Let's see. Do any of you agree? Okay. What do you think is the center of the universe, guys? Any idea what is the center of the universe? I think according to the Vedas, the sun is the center of the universe, isn't it, guys? The Lord God Sun, things like that. So we're saying sun is the center of the universe. Let's go to the next one. Well, if you go back to history, people assumed Earth was flat. And I don't know whether it is Aristotle or Copernicus. When he said Earth was not flat, he was jailed. Isn't it, guys? Do any of you remember who was that guy? Who was that philosopher? Copernicus, huh? Galileo. There you go. Galileo. Good one, guys. I forgot about that. So let's move on to the next one. Continents do not move. How many of you think continents move, guys? Yes or no? Okay. Okay, good one. If you're watching Discovery Channel and things like that, you're probably coming across the continental drifts and slight location. I think if you go back, I know there's also a theory saying that Australia was the Lanka in the olden days and things like that. But we don't know. There's a little bit of things. The next one is stress causes ulcers. How many of you think stress really causes ulcers? Does stress damage your body? Very good, guys. It seems 90% of the patients getting into the world of hospitals, they are getting into hospitals not because of physical injuries, but because of the mental injuries. What is mental injuries, guys? The stress. So stress is very important. It is probably causing the ulcers, guys. So the next one is 10,000 hours of appropriately guided practice is the magic number of greatness. Malcolm Gladwell is a popular author. I have not really read, but I think he wrote a book in which he mentioned you take any one job, one task, and you practice it a lot. What he really means is you practice it. He said you practice something for 10,000 hours, you'll become perfect, is what Malcolm Gladwell said. And a little bit of philosophy, if you go to the Vivekananda's philosophy, he says, if you become perfect in one thing, you will become perfect in everything, is what it is. 1,000 kicks, huh? So there is Santosh, guys. He's reminding about Bruce Lee. Bruce Lee says, fear not the man who knows 1,000 kicks, but fear the man who practiced one kick 1,000 times. So almost everything is rotating around the same thing. Lalita says she disagrees. Let's see what is. Okay, now here comes a big one. How many of you think men are better drivers than women, guys? That's a controversial thing, isn't it, guys? Okay, lots of yes, lots of no's are coming up there. Interesting, I can assume, I can understand that and things like that, guys. Okay, so it seems there was a study conducted and they tested men and women. They were driving the cars and things like that. What they observed was generally women are more They're more kinder, they're more gentle, they're more soft and things like that, which is a good thing. But in intersections where there are more than two roads or three roads, women tend to get a little bit more tensed. Okay, upon digging a little bit deep into it, it was understood that women were, yes, they were panicking a little bit. That is because, or in other words, more precisely, they ended up understanding that men genetically developed a slightly additional resistance than women when it comes to the outside world. It is only in this century, or the way, last few years, few decades, women started coming out. Women were not really going out doing the outside jobs and things like that. So that is the reason why men were going out all the time, and that's why they have developed an additional resistance, is what is the theory or the story behind it. But I think personally, if you were to replace all the auto drivers, taxi drivers with women, okay, I think because women tend to be a little bit more kinder, they tend to be a little bit more slower in driving and things like that, there would be much less number of accidents. They are better. They end up making the roads more safe. Do you think you agree, guys? Little bit of fun there. Sorry about that. Yeah, there is a good point, guys. We can prove it. So, gentlemen, what are all these statements, guys? Can you take a guess what these statements are? Time will be taken. They are facts. They are data. Good. So, what are those, guys? Those are assumptions. In a general world, those are called assumptions, guys. So what is that? In a business world, they are called hypotheses. Okay? So we've been referring about hypothesis testing and things like that. So let's apply these things in a business world. Let's take an example in a business world, guys. No difference in performance of the sales team across geographies and product lines. In other words, what it is telling is, imagine we are saying there is a sales team, there are different sales teams, some in East Zone, West Zone, and North Zone. And if there are different sales teams in a business selling different kinds of products, do you think all these sales teams, their performance will be same in different cities, in different zones, or will they be different, guys? What do you think? They will be different. You might think. But what is emerging here is, let's say the no difference is emerging. Somebody is saying there is no difference. Somebody is thinking, hey, all the sales teams are performing the same. Then come to the next one. Change in gas prices, gases, petrol, will have no impact on losses in automotive finance. In other words, today, I think roughly 1 liter of petrol is maybe 80 rupees, roughly, close to 75 to 80 rupees, guys. Imagine for the sake of simplicity, it becomes 100 rupees. Do you think a lot of people will continue to buy the bikes and the cars, or will they? It's 90 rupees, good, that is good. Do you think they will continue to buy more bikes and cars, guys? How many of you think yes or no? Good. A lot of them are saying no. Okay. So, but what is happening? They're saying no impact, which means somebody is saying there is no difference. People will continue to buy. Well, if what is 90 rupees becomes 100, there might not be much difference. But if 90 rupees becomes 1,000 rupees, I'm sure definitely that will be a huge impact, guys. So let's take another one. Change in CEO will have no impact on the stock price. Do you think if the CEO of a company changes, the stock price will change, guys? That's a tough question. Will it impact the stock price? Lots of yes are coming. Well, that's a good question. So we'll have no impact. What is no impact, guys? No impact is again somebody saying there is no difference. Okay. Real estate yields are same across all the metros. Do you think rentals are same in Hyderabad, Vijayawada, Mumbai, Chennai? They're the same? Okay. So in other words, they are the same. Means there is no difference. Okay. And the last one says compensation changes will not impact attrition. Attrition means a group of employees are leaving. Employees leaving an organization because of some reasons. What's happening? Some are being paid high, some are being paid low. What's happening? Somebody is saying will not impact. What is that? That also means there is no difference. Okay. So what are all these things, guys? These in a business world can be thought of as assumptions. In a business world, we refer them formally as hypotheses. In a friendly way, we can say these are called hypotheses. Somebody is assuming these things. Everybody with me, guys. Quick yes, please. Okay, so let's go one step forward and see what is happening. So there comes hypothesis testing. What is hypothesis testing is? It is a method of making an inference about a population parameter based on sample data. That's an academic definition. About a population parameter means that is mean or standard deviation. That is average or standard deviation. Because somebody is making an inference means they are saying, hey, the average salary of all the data scientists is this much. The average salary of all the mechanical engineers is this much. Okay, what is that? That's a conclusion. That's an inference they're making. And what is it? It is a statistical technique or analysis used to determine if the difference observed in a sample is not a random occurrence but a true difference. Okay, let's say there are 10 people, and let's say come here. Let's say Nanda Kishore is the first guy. Let's say he's making a salary of 50,000 rupees. Let's take Ramakrishna. Ramakrishna is making a salary of 100,000 rupees. In other words, here is Kishore at 50,000, and let's say here is Ramakrishna making 100,000 rupees, which is 1 lakh rupees. Let's say all the guys are making a salary between these two. Now let's come here. Let's pick up. Let's say, who do we have? Kalyani. You picked up Kalyani randomly, and let's say she's somewhere in the middle. She's making 75,000 rupees per month. Okay. Now what is special about it is she is much more. She is in the range of 50 to 100,000 rupees. What is she? We picked her up randomly, and what is happening is she is between 50 and 100,000. Everybody is between 50 and 100,000. But let's take another guy. Here, who do we have? Ishwar. Let's come to Ishwar. What is special about Ishwar? He's making $1 million. He's $1 million guy. He's too far away from the majority of the people. In a slightly simple way, in a slightly simplistic way, let's say we randomly picked up Ishwar. His salary is coming to be $1 million. Now, can we say, is this a random occurrence or is this a true difference? What is that? That is hypothesis testing. Hypothesis testing is suggesting is something very rarely occurring. Is this random, rarely occurring, or is it much more close to the majority of the options? Is what is about hypothesis testing. Okay, guys, that is like a friendly definition of hypothesis testing. Quick yes, please. Cool. So let's come back here. 8:39. I will continue our discussion for about a few minutes, and I will stop the last 10-15 minutes for a few questions, guys. Somebody was asking what is the duration. On a daily basis, we'll be following this, guys. The first week, I will be focusing on a little bit of theory, on a little bit of theoretical concepts, and try to get you up to speed so that in the coming up days, I will start getting into the code, and you will also, we will start using these things, guys. So, what is that? That is what is hypothesis testing. Let's dig a little bit deep. In the world, in a statistical world, what happens, guys? Here's what happens. These are, in the world of hypothesis testing, these are the common terms that we also use. Confidence interval. Confidence interval, here is a formal definition. You don't need to by heart these things, but we need to have a rough idea. What is confidence interval is? A formal definition says it's a measure for reliability of an estimate. Sample is used for estimating a population parameter, so we need to know the reliability of that estimate. In other words, imagine, let's come back here. Let's take Subhani. Subhani is a fan of cricket. Imagine there's a cricket match tomorrow between India and I think right now they're playing with Australia, tough team. I think they lost very badly recently. Right, guys? So now, what Subhani is saying is, imagine Subhani is a statistician. He comes back, let's say somebody asks him, do you think India is going to win the next match? What will Subhani say? Because he's a statistician, Subhani will say, India is going to win, and he will say whether he's 95% confident or 99% confident. Okay, Subhani may say he's 95% confident that India will win. Okay, let's take Ashok. Ashok is. Let me redo the example, guys. Let me redo the example. Let's say instead of India winning a game or not, let's take Sachin. Imagine Subani is a common man, not a statistician. And let's take Venkat. Venkat approached Subani. He asked Subani, what is Sachin going to score? And what is Subani doing? Subani is going to just throw a random number. He's suddenly coming and saying, hey, Sachin is going to score 50 runs. That's all. But back to Venkat. Now he goes to Srinivas. And he asks Srinivas, what is Sachin going to score? And Srinivas is a statistician. What will Srinivas do? Srinivas will now say, he is expecting Sachin to score between 40 and 60. He is expecting Sachin to score between 40 and 60, and let's say he is 95% confident. What is that? That is what is confidence. What is this 40 to 60? The 40 to 60 is referred as the confidence interval, and 95% is called as the confidence level. This is a statistical way of how a statistician answers a question. Generally, what do? They give a range. The range is called the confidence interval. And whether they are 95% confident or 99% confident depends on the an analysis that you're performing. What is it? That is called confidence level. That's a slightly tough one, guys. We'll try to we'll give another attempt maybe tomorrow and try to simplify it. But everybody okay, guys? Everybody catching the point there? Can you give me a quick yes? Okay. Then we have degrees of freedom. What is degrees of freedom? Again, a little bit of statistical terminology. A simple definition is, imagine you went to a car rental store. There is only one car. There's only one car to rent. How much choice do we have? Well, we say we have no choice because there's no other car. We have to take this car and just drive it. What is that? That is degrees of freedom. Degrees of freedom is number of values, number of choices you have minus 1. If there are 2 cars to rent, your degrees of freedom is n minus 1, 2 minus 1, that is going to be 1. That is called degrees of freedom. Okay? In other words, the mantra of degrees of freedom, in a slightly simple way, think of it as n minus 1. Okay, another big thing. Here comes the big thing, the p-value. This is a formal definition, guys. Probability of obtaining a test statistic at least as extreme as 1 that was actually observed, assuming that the null hypothesis is true. So we need to understand what is null hypothesis. We'll try to attempt that maybe tomorrow. Okay? But think of p-value is a percentage of error or the chances of error. Generally, the 5% is called the global standard. That's a little, maybe today I will not talk much about it, but we'll revisit p-value, guys. Here is another look at confidence interval. So let's look at this and see if we can wrap up here for today. Take a look at this guy. Here's what is happening. This guy is looking at the weather. Choose this one. This guy is looking at the weather in a TV. They're saying, take a look at tomorrow's weather. And what are they saying? The high temperature will be between 40 below 0, which is minus 40, and 200 above, is what the weather reporter is saying. And what is the audience? What is this guy thinking? This guy is thinking this guy is never wrong. What is the weather reporter is saying? It is minus 40 to 200 above. If you go anywhere on Mother Earth, it is always going to be true. It is like saying, imagine there's a cricket match tomorrow. You're asking somebody what Sachin is going to score. It's like saying he's going to score anywhere from 1 to 1000. What is special about this one? This is a range. But what is special? You can be 100% confident. It might be 1 to 1000 or 0 to 1000. You're 100% confident. But this is not practical. This is not useful for anybody. This is not useful. This will not help you in deciding whether you should take an umbrella or whether you should take a raincoat, or maybe it is not necessary to take an umbrella or raincoat. Everybody catching it, guys? Can you give me a quick yes, please? Are you catching the point? In other words, what is that? That is confidence interval. That range is confidence interval. What is special about it? That should be practical. That should be in a way where it should be useful and helpful to others, not just a big numbers is what it is, guys. So what is that? Again, it describes the reliability. It should give you some reliability. So let's do a little bit of cleanup here so that you can see everything. It should be reliable. It should be practical. It is nothing but a range. It gives you a width. That is called confidence interval. And Generally, what do statisticians do, guys? When they give a range, they will also come back and say how much confident they are. Whether they are 95% confident or 99% confident, that is called confidence level. It is a probability associated with the confidence interval. Okay, guys, everybody with me? Quick yes, please. Okay, with that, for today, what I would like to do is I will open the floor for a few questions and answers. We will continue our journey again tomorrow at roughly at around 7:30, guys. So it's questions time, guys. So far, has it been making sense, and does it look like it is helping you and useful to you and helpful to you, guys? Good to know. So I think Manasa has forwarded the feedback form. Please feel free to fill up the feedback and let me know and things like that. So open it up for questions, guys. I will give you anything technical. I will be able to answer, guys. Anything which is not technical, Manasa will be getting back to you for your question. So you can put the question. Manasa will take care of it. Data mining techniques are used. Yes, the data mining techniques are nothing but the machine learning. Data mining is a slightly old-fashioned name, but the machine learning, the deep learning is like more of a modern name, and mostly data mining was used from a business intelligence perspective, which again we are here to discuss, guys. So data analytics, artificial intelligence, you don't look at Django. Django is more of a UI development, a web UI development. It's a framework for web UI. That is not part of data analytics or data science. It is not a must, guys. Neural networks are part of the deep learning, more precisely. Think of deep learning as an advanced machine learning, a group of advanced machine learning algorithms. In the coming up days, we'll be providing the PDFs and things like that, guys. Books, there are there are a bunch of books, guys, but let me see. Sorry about that. To start with, O'Reilly publications, Oreilly, any of the O'Reilly publications are generally good, guys. I will try to pick up one or two and pass on the names maybe tomorrow. Recorded sessions, all those things are not under my control, guys. I think they'll be putting them on YouTube. Somebody will be getting back to you on that. Statistics is important, but you don't need, remember, the mantra is you don't need to be a mechanical engineer to drive a car. You don't have to be an expert. You should have some familiarity. Later, when we use these terms and things like that in the coming up days, you should be comfortable. So a little bit of theory, guys. Yes, the first 1 week, I will be explaining a few terms and terminologies, so bear with the theory. It will be easy for you to understand in the coming up days. Bad at math. You don't have to be an expert at mathematics. Again, generally, in the courses to be taken and things like that, the required amount of mathematics is explained, and you should be good with that, guys. First thing, let me see. I'm having a little trouble looking at the chats here, guys. What is ANOVA? ANOVA test is used when you have when you want to compare the means of 2 or more samples. In coming up days, I'll probably give you a touch of it. To start, for data science. First thing, a little bit of Python programming. Theory is theory, but a little bit of Python programming, if you have a little of that. Using Python, that is, Python is the latest and the greatest, and the entire world is after Python. Voice is good. Oh, thank you, buddy. Some good comments coming there. Appreciate that. Yeah, we'll be sharing the PDFs at the end, guys. And in the coming up days, we'll be sharing, because a lot more content is getting added. We'll be sharing it. Oops. Lots of how to select AI projects, recommended books on AI. So again, O'Reilly publications, Oreilly, guys, those are the ones. Hands-on machine learning and data science from scratch are a couple of things We'll be using Python, Malika. Oh, I'm sorry, who that is. I think at the end they will be giving you a certificate. And we'll try to do, a project is a big word, guys, whereas here we'll try to look at a few scenarios and try to understand how we use data science and AI, how it is using in real world and things like that. If time permits, we'll also look at a chatbot, guys. Chatbot, computer vision, NLP stuff, we'll be looking at those things also. I think it is just 3 to 4 weeks, so we cannot go into a lot more detail, but we will try to give you a good, decent understanding of them. Python websites. Oh, Google is your friend, buddy. Start with, some basic websites in Google. Pardon me. I'm sorry. Go to Google, do a little bit of Python introduction. I will also give you a touch of it, but brief on variance again. Variance is a spread, Manasa. Could you please brief on variance again? Oh, variance is a spread. It is giving you a picture of what is the spread of the data, is a short answer. Hypothesis testing, yes, we'll talk tomorrow also. Algorithms also, in the coming up days, I'll give you an example of them. Machine learning, yes, we'll talk. Roadmap. Uses of Python. Yes, those are coming up, guys. In coming up days, I'll give you a touch of it. Role and responsibilities of ML and AI. Okay, math is fun. So looks like some people are posting some. Ramakrishna has posted math is fun website. Do I need to learn No, it's not necessary to learn SPSS. The Python is like the ambassador car, guys. If you learn how to drive an ambassador car, you can drive anything. The other things will become a lot more easy. How long we need to spend. It depends on, there's nothing like, a minimum 3 to 6 months would be a good time. It depends on where you're learning, with whom you're learning is also. To become a AI professional, guys. Again, for those of you who are coming from no programming background, just do a little bit of reading, get a little familiar with a little bit of Python, guys. SQL is important, but very important is Python. Fast AI, yeah, those are some websites, those are some specialized libraries, packages. Zero knowledge of Python is okay, not a problem. Like email, WhatsApp with the instructor. Okay, I'll be sharing my email address, guys. You can try to send me some questions here. You can also send to me. So that's my email. And if you, very good, Shravani, thank you. I appreciate it. Okay, nice of you. And are you? Yeah, I'm not from Vijayawada, I'm from Hyderabad, guys. We are Naresh Technologies from Hyderabad, helping our AP skill development team. Just to get far enough in Python. Yeah, that's okay. If you have a little bit of Python, it will be helpful. Then later you can try to. Yes, I speak Telugu, guys. I'm a Telugu. Andariki Vandanamulu. Let's see what else we have. Okay. Thank you, guys. I appreciate that. You're trying to connect to me. Okay. Data structures. Yes, that is enough. Up to data structures in Python is enough, guys. You don't need advanced Python. Here we'll be using NumPys, Pandas, we'll be getting a touch of it. Thank you again, guys. Some good comments coming out there. Sportsmanship, that is good. Keep it up. Very good. Okay. So what we'll do, guys, for today, I will stop it here. Let's continue from tomorrow. You guys take care. Don't eat outside too much. Don't go to restaurants and things like that unless it is necessary. You try to stay as much safe as possible. The second wave is being talked about, guys. So try to be as much safe. Don't take chances. and try to eat as much as you can at home and things like that, guys. Sorry about that preaching, but due to this time, just a friendly suggestion and advice. So we'll continue the journey from tomorrow. I will be signing off for today, guys. Thank you all.
Thank,
Take care, stay safe, keep learning, and bye for now. Thank you again.
thank you, sir. Thank you, sir. Thank you, everyone. And regarding the recorded videos, they are available in the YouTube. You can find it in the same link.
Yeah, thank you, Mansa. And the most of the members are continuously asking about the feedback link. It's already clear. End of the session only, we will place the attendance form, everyday attendance form. For the certificate minimum, based on the feedback only, we will collect the attendance. Okay. So end of the training, we will conduct a small test, and as well as we consider minimum 80% attendance. So that is the mandatory. Every day, last 15 minutes, last 5 to 10 minutes only, we will place the attendance link as well as feedback form. Okay, can you share the YouTube link, guys? For we already shared the YouTube link through your register mail ID, and we every day we are placed in our Telegram groups also. Okay, just follow the Telegram group every day. You get the information. And some of the members are repeated the same questions continuously, so because more than 1,000 people, nearly 1,000 plus people are watching in the airmeet as well as YouTube. Try to avoid same questions, because the speaker need to cover many answers. That's why. Yeah, end of the session we will provide the certificate based on the attendance as well as exam. The feedback link is nothing but attendance link, both are common, don't worry. Just this is the exam is nothing but just online assessment test, that is the like MCQs only, don't worry. Already sir is told many times, end of the training we will provide the material also. Okay, and some of the members are asking about the uh, yeah, videos. Just follow the APSSDC YouTube channel, every day you get the videos link. Okay, and yesterday link will be not provided, because end of the session, every day end of the session only we will provide the link. End of the session only we will provide the all the material and PDF with your certificate. We are posted many times in the chat box, live chat box, and as well as in YouTube we will already posted in description box. Okay, check the description box, as follow the chat box only. Just follow the YouTube channel, APSDC YouTube channel. Okay, in that you get the recorded videos. Yeah, currently the registration is already in still open. I think some of the members are asking about the how to register. So already the registration link is apssdc.in. The registration is also mandatory. So you see that this is the apssdc.in home. You see that the training on data science and AI using Python in collaboration with Naresh Technologies. Just click on here. Just register here. Okay. So not only the APSD is conducting many programs. So this is the Infosys recruitment drive for the diploma holders for 2019 and 20 passed out. So 24th is the last date for the registration. The role is the operation executive. So just check it here. So this is one of the opportunity for the 1920. So this is the one more program. This is the artificial intelligence and Wipro Elite. I hope for 2021 passed out. Wipro is launched the 2021 assessment examination for the recruitment process. So many trainings is available. So just follow our APSDC channel .in website. You get the daily information about the all these programs. Yeah, YouTube. I'm already mentioned. Sir also already told. The end of the training only we will provide the material and PPTs. Okay. Feedback link already placed in description box. Check the description box. Yeah, thank you everyone. Thank you everyone. Thank you. Outside of AP also allowed, not a problem. If anyone interested, we will allow outside of AP candidates also. Thank you guys.
Thank you, Murli. So if you have any more questions, you can post it in the feedback form. There is an additional comment section there. So you can post it there. Thank you, everyone. Thank you.